Hey students, you guys were supposed to read about Newton's second law on pages 46 to 47, and I just wanted to take a minute and go over some of that with you just to make sure that you guys, really understand this. So the second law states that an object's acceleration, so how fast its speed is changing. So if it's speeding up or slowing down, it is accelerating. So its acceleration depends on its mass and the net force acting on that object. So another way we could say this is force equals mass times acceleration. So if we know the mass of the object and we know the rate of its acceleration, we multiply those two numbers and we find the force. But before we can do that, we need to understand the units. So our unit for force is newtons, capital N. Our unit for mass is kilograms. I know we've talked that you can use like any unit of grams, but for these equations, you have to use kilograms. And the unit of acceleration is meters per second squared, or m/s squared. So I would write all of this, take a minute, pause this, write this in your notebook, write it on a piece of paper, because we'll need this. So write this down somewhere. So Luke used the mass times acceleration. If you get it, you'll laugh, or maybe not. Okay, so force, get it, mass times acceleration. Here's the example. So if we have a person with a mass of 80 kilograms and the person is accelerating, I don't know why I wrote it, but this person is accelerating at a rate of 2 meters per second squared, what is the force acting on that person to cause that acceleration? And so force equals mass. What's the mass of our object? Mass is 80 kilograms. And its acceleration is 2 meters per second. So force equals 80 kilograms times 2 meters per second, or 160 newtons. So for the sake of these equations, you can just write the numbers and then just know, well, we're talking about force, and so it's going to be newtons. You might be like, well, where do you get newtons if we've learned before, like, if you have centimeters per second and it's centimeter cm/s, like where are we getting the newtons from? I can explain that, but it's a little bit complicated, and all you need to know for right now is, okay, we're talking about force, it's going to be newtons. If we're talking about mass, it's going to be kilograms, and if we're talking about acceleration, it's meters per second squared. You just know those units for now, we'll be fine. So we have a dog sled. This is on page 46 of your book, and you should have filled this out already. And my face is covering, actually, I can move it. I did not know that. Okay, so here's our dog sled team, and it's saying, how would we increase the sled's acceleration? So if we want our sled to go faster, I think this is kind of more common sense stuff. So if you have this going on and you want to go faster, what do you need? Well, I would think you would need more dogs, right? So that'd be more force. So if you add a dog, it's less weight for all the dogs to pull, and it's going to go faster. Or if you keep your dogs the same and you take away one of these people, you'll go faster too. So that's how we increase acceleration, more acceleration. How would we decrease? So if we want to slow our sled down, I would think if you take away a dog and leave the mass, you're having less force pulling on these people. Or if you keep the dogs and you add more people, that's going to also slow you down. So that's how you do those. And I'll move my face again. Okay, so acceleration, force equals mass times acceleration. If you rearranged those, you could make acceleration equals force divided by mass. You don't need to know the algebra behind that because that's what it is. You just need to know the second equation. So they're the same equation, it's just moved around parts. So if you write this down, write this in your notes, acceleration equals force divided by mass. So again, same units, newtons for force, kilograms for mass, and meters per second squared, if it goes away, for acceleration. And here's another example. A box that is 40 kilograms has 120 newtons net force acting on it. What is its acceleration? So if you are looking for acceleration, that tells us this is the equation we should use. Now, if we were looking for force, we would be using the force equals mass times acceleration. So use the equation based on what you are missing. So whatever you're missing, that is the first that's going to go here. So it's the force, so 120 newtons, divided by, remember that's what that means, divided by, and if you put that in your calculator, the little divided, the little slash, and that's going to divide, divided by the mass, which is 40 kilograms, you get 120 divided by 40 equals 3 meters per second squared. Again, you don't need to know why am I doing meters per second squared when it's newtons and kilograms, because I said so. Because that's what the units are. Again, if you are like extra curious and you think this is cool, you want to know why, let me know. I'll explain to you why the units are what they are. But for now, you don't have to. Okay. Every year, cities around the world, teams create cars, push them off platforms, and hope they fly. This is real. I'll put a video on Canvas. Unfortunately, the cars always end up accelerating down into the water. Yeah, okay. So if a car has a net force of 100 newtons and the car is 50 kilograms, what will its acceleration be? So think of our two equations, right? Force equals mass times acceleration, or acceleration equals force divided by mass. We have the force and we have the mass, we don't have the acceleration. So we're going to use the acceleration equals force divided by mass. So our force, 100 newtons, divided by 50 kilograms, equals 2 meters per second squared. So this car is accelerating at 2 meters per second squared off the ramp, right? So it's going at 2 meters per second off the ramp. And then gravity comes in. Okay, so I don't think we covered this, but gravity, the force, the gravitational force on an object is its mass in kilograms times 9.8 meters per second squared. That is just the rate at which things fall on Earth. This number is different on every planet or moon. So all we do is we do mass times 9.8 meters per second squared. And so if our mass, move me out of the way, go away, Mrs. Roach. Mass is 50 kilograms times 9.8 meters per second squared. Our force of gravity pulling on this car is 490 newtons. I think that's crazy because these people, a team of people had 100 newtons, and then gravity is 490 newtons. So gravity is really strong. All right, finally, these equations, force equals mass times acceleration. What is the net force? So force equals mass times acceleration, mass, and acceleration. So 4 newtons, that's our force. Okay, you had to think about it a little bit. So if the mass of the skateboard doubled, right? So it was 2 kilograms, now it's 4. But the net force remained constant. So we keep this 4n. Okay, what would the acceleration be? So we have to use our acceleration equation. Acceleration equals force divided by mass. So A equals the force, which we kept the same, 4n, divided by the mass, which we now said is doubled, so 4 kilograms. Our acceleration is now 1 meters per second squared. That should be a 2. The acceleration would be reduced by half. So before, with 2 kilogram skateboard, you were moving at 2 meters per second squared. When you have that same force pushing on the skateboard, but more mass, it's now only 1 meters per second squared. So it's going at a slower pace. All right, if you guys have questions, send me a message. Hope this was helpful.